Okay, here's a little bit of an interactive tool that might help you understand this theorem a little bit better. I'm going to go ahead and work through a couple of the slides, but I'm also going to put the link on your Google Classroom so that you can work through it.
The longest distance inside a box is the length from a bottom corner to a top corner on the opposite side. If you needed to find the length of the longest pole that fits inside a truck trailer, you would need to understand the Pythagorean theorem. The Pythagorean theorem describes the relationship between the lengths of the sides of a right triangle. A right triangle is a triangle with a 90-degree angle. The side opposite the right angle is called the hypotenuse, and the other sides are called the legs. The Pythagorean theorem states that if a right triangle has legs of lengths A and B and hypotenuse of length C, then A squared plus B squared equals C squared. To see that the Pythagorean theorem works, start by recalling that a square with side length S has an area equal to S squared. Now imagine forming squares at the sides of the triangles. The squares have areas A squared, B squared, and C squared. The Pythagorean theorem states that A squared plus B squared equals C squared, so the squares at the legs must be equal in area to the square at the hypotenuse. Move the pieces from the squares with sides lengths A and B to the square with side length C, and notice that A squared plus B squared equals C squared. Here is a different right triangle. Drag the pieces from the squares at legs A and B to the square at the hypotenuse to verify the theorem again. Here is another way to visualize the Pythagorean theorem. The squares formed at legs of length 3 and 4 will have areas of 9 and 16 unit squares. The square formed at the hypotenuse has 4 squared plus 3 squared, or 25 unit squares. The length of the hypotenuse is therefore the square root of 25, or 5. Here is an algebraic proof of the Pythagorean theorem. Start by making 4 copies of a right triangle. The area of the inside square is equal to the area of the large outside square minus the area of the 4 triangles. Using the Pythagorean theorem, if you know the length of 2 sides of a right triangle, you can find the length of the hypotenuse. A triangle with sides of length 5 and 12 will have a hypotenuse equal to the square root of 5 squared plus 12 squared, or 13. Use the ruler to confirm that the relationship between the lengths of the sides of the right triangle is described by the Pythagorean theorem. Using the Pythagorean theorem, if you know the length of the hypotenuse and one side of a right triangle, you can find the length of the other side. A triangle with hypotenuse of length 10 and one side of length 6 will have another side of length equal to the square root of 10 squared minus 6 squared, or 8. Use the ruler to confirm that the relationship between the lengths of the sides of the right triangle is described by the Pythagorean theorem.